Hi, welcome to our presentation. This is Group 4.1. Today, we are going to introduce our model, an all-round AI doctor with rich data source and functionality. Here is the overview. We will cover the following parts, from an introduction to future recommendations. Our model is called AI Doctor, revolutionized healthcare. Think about it. When you get some daily ailments like sneezing or runny nose, you don't want to take money and time to see a real doctor. Then you can visit our AI doctor. With the development of large language model, this is becoming a reality. The market is grabbing this opportunity. Microsoft take the lead, released their Azure MetaBot in 2021, followed by Google and Meta. All of these models have some outstanding features. Our model is basically based on ChatDoctor by Meta AI and share a similar architecture. Along with the opportunity, there comes a lot of challenges, like the data sparsity and the privacy concern, hallucinations of large language model, and it's hard to use for the elderly. So we are aiming to build a new model to solve these challenges.
We utilize more than 5 models and realize more than 5 functionalities. This is a demo of AI Doctor. The doctor can tell if the problem is medically relevant. When we input medical related content, the doctor will give suggestions. We can press this button to use the prediction function. And at this time, the doctor will make recommendations for the next question. We can also use reg and tune parameters. When we use reg, doctor can draw on rich knowledge base and make recommendations. Rich knowledge allows doctor to make more precise and accurate recommendations. We can continue the conversation to get more advice. In addition to text input, we can also input a piece of audio. We can click the button here to record. The user is also allowed to record multiple times. After submitting, the doctor will make a judgment. User can ask AI doctor to make further recommendations based on this diagnosis. Our AI doctor chatbot can receive two kinds of input. When user inputs text, the doctor will judge whether it is medically relevant. If it is not relevant, the doctor will prompt the user to input medical questions. If it is relevant, our doctor will extract keywords and give answers. User can also use RAG so that doctor will utilize our database to generate more accurate answers. When the input is an audio recording, the doctor will diagnose whether he is healthy or not and finally give a judgment.
Here, I will introduce our novel approach to realize the user intention classification. We first concatenate each intention with customer query as a whole or sentence. Based on the idea of selecting user's intention with the highest sentence probability, we derive from equation 1 to equation 3, which is our final optimization model, and it can be directly solved by decoder-only architectures like Phi 1.5. The idea of online auscultation is based on the following paper, but in order to faster response speed and conserve computation resources, we simplified it. The dataset is obtained from the author, and we convert the wave file to Mel spectrum features, and we classify the sound and input the result to LLM for integrating response. The core of RAG is retrieval plus generation. The memory of large language model is limited, so we build a database for it. And moreover, we utilize the embedder for recording relevant pages. And the summary work is for the LLM, which is its strength aspect. Next, I will introduce the framework of our core part of AI Doctor. We leverage pre-trained Llama 2 model and fine-tuned by two tasks: mask language modeling on medical books and prefix learning based on real doctor and patient conversations. This model is applied to 3 downstream tasks, which are core parts of our application.
Well, this slide shows a highlight of our work, keywords extraction. The picture below shows how we use BERT model and the categorizer to extract keywords from patient questions. The bottom is one of our real demonstration cases. You can see that the model accurately extracted the 3 keywords of the patients: cold, headache, and suggestions. Another innovation point: predict next question. The picture at the bottom shows how we predict the next question. You can see that we combine historical conversations, including patient and AI doctor, with keywords to help our model generate prediction for the patient's next question. This slide shows our model data size and their proportion. You can see that we use data from the Healthcare Magic website. The MedQA, it's patient and doctor real conversation data set. At the same time, we pre-process and visualize the data.
Here we assess deep learning models for online auscultations. The graph compares ResNet versions and UNet on precision, recall, and accuracy. UNet notably leads, indicating it as a top choice for remote medical sounds classification. We also dive into user feedback, comparing the efficacy of long-form answers from 3 different sources: the real doctors, chat doctor model, and the AI doctor model. The data shows us that AI doctor significantly outperforms the others in being rated as extremely helpful, with substantial leads over chat doctor and even human physicians on the Multimed QA dataset. This underscores AI doctor's capability to provide highly relevant and precise medical information. Following AI doctor's positive user feedback, we employed BERT score for deeper analysis, confirming that AI doctor, especially with the RAG enhancement, outperforms in semantic accuracy. This benchmark against the actual physician responses from a clinic database shows our model's superior grasp in generating relevant medical answers. AI doctor with RAG's lead in precision, recall, and F1 score illustrates its advanced understanding, essential for medical AI applications.
For the recommendation in the future, if we wanna get better performance, we can scale up the model size and make it a faster inference. And then we need a wider range tests. Okay, that's all. Thank you.